Hi everyone. Um, Today's lecture is for week 8, and we studied in the previous lecture comparison of two sample proportions, and we had only two examples. So we will be doing this week some exercise, the remaining exercise in the book, some of them for an hour of lecture. Um, Before I start the lecture, I want to show myself, to show up myself as a video file. But I will keep going with the notability without my picture. I tried to use an iPad and a PC to place both um, my face and my writing at the same time, and I had a big trouble. So I will just show myself sometimes. You can see me sometimes. I'm gonna be going um, with the notability using. So this is, remember, this is from the previous lecture, the previous lecture, and this one is supposed to be on the 23rd of March, week 8, and we will start with exercise 11.54. I already copied for you, prepare it just to not to lose time, not to waste my time. So I'm going to read you this exercise. The exercise 11.54. A bank manager has been presented with a new brochure that was designed to be more effective in attracting current customers to a personal financial counseling session that would include an analysis of additional banking services that could be advantageous to both the bank and the customers. The manager's assistant who created the new brochure randomly selects 400 current customers, then randomly chooses 200 to receive the standard brochure that has been used in the past, with the other 200 receiving the promising new brochure that he has developed. Of course, receiving the standard brochure, 35% call for more information about the counseling session, while 42% of those receiving the new brochure call for more information. Using 0.10% level of significance, 10% level of significance, is it possible that the superior performance of the new brochure was just due to chance and that the new brochure might really be no better than the old one? Okay, let's start the solution. Um, we need to construct first the null hypothesis. So the null hypothesis will be equality. We have to have an equality for the null hypothesis, and the alternative hypothesis should be pi 1 is less than pi 2, because the new one should be no better than the old one. So it means pi 1 is the new one and pi 2 is the old one, so pi 1 should be less. That's how you construct it. Alpha is given to be 0.10 and 1 is 200, and 2 are identical sample size, 200 another 200. So P1 and P2 are the proportion, the successive proportion, to 0.35 and 0.42. So before you get the calculation of the Z statistics, you need to get the common mean proportion, which is pi bar. That's the 1 pi bar times pi bar equals n1 times p1 plus n2 times p2. That's divided by n1 plus n2. And this equals to 200 times 0.35 and plus 200 times 0.42 divided by 200 plus and 200. And the result is, I get this calculation already, 0.385. Actually, I did this calculation. I was trying to record this half an hour ago, and I failed to do so. So I don't want to rewrite all this stuff again. I'm gonna show you how you perform all this. So the calculated statistic, remember from the previous lecture, it was pi1 p1 minus p2 divided by the square root of p bar times 1 minus p bar times reciprocal n1 plus reciprocal n2, and you substitute all the result within the z calculated statistics, and you find that this is minus 1.4384. So you need to know whether as a decision rule you need to place it, you need to have a representation of graphical representation of the standard normal distribution, and you need to find the place for the critical region, the critical value. The critical value, you bring the critical value as a decision rule, you need to bring the critical value. So I did it half an hour ago, I have it in here. So 0.90% is the accept probability and 0.10 is the rejection probability. So this table is prepared in different way. Remember from the last week, as I told you, this is, you don't use the alpha levels directly. What you do is we subtract the alpha level from 1, which is 1 minus 0.10 becomes 0.90. So 0.90 is the closest one, is 0.8997. This is the closest. And since this is 0.90 becomes 1.2 from the rows and 1.8 from the columns. See that? This is, I'm gonna highlight it again. Sorry about that. Okay, I'm gonna highlight it with different color. So this is 0.8 and 1.2 from here, and that's 0.8997. Okay, so I know that this is 1.28. So since this is a left-sided hypothesis, I place it on the left side. That becomes the minus 1.28. So the calculated statistics is simply falling within the rejection region. So I'm gonna reject the null hypothesis and conclude that the new brochure is worse than the new one, so it's not really better than the new one. So this is for sure, it is less than, it falls within the rejection region, and it's easily, you can easily reject the null hypothesis. Okay, let's move on to the next exercise, which is 11.55. I'm gonna copy the exercise from the book. 11.55 right here, have it here. Let's see, copy this. I'm gonna place it into my lecture note. Okay, right here. Okay, right here. Fine here. Okay, enlarge it a bit. Maybe that's fine right here. No need to have it in a bigger font size. Gonna have it even fine. And the remaining part for the 11.55 exercise is actually in here. Okay, copy this, go back to my lecture notes, place it right here. Okay, gonna enlarge it. That's fine. Okay, the next exercise, 11.55, in examining the ability of user to complete a variety of information seeking tasks on their mobile devices. Nils and Norman Group assigned sample members to get the answer to a variety of questions like how many calories are there typically in a slice of thin crust pizza. The success rate for achieving such task was 75% for those using touchscreen phones like the iPhone to access the mobile internet, compared to 80% for persons accessing website on a conventional personal computer. Assuming these percentages to be based on independent sample of 500 persons each And using the 0.01 level of significance, can we conclude that the population success rate with a conventional PC is greater than when using the mobile internet and touchscreen phone? Okay, I guess the question is, you can easily understand the question. Okay, I'm gonna write here. Okay. So let's start the solution right here. I'm gonna use the space remaining on the right hand side for the solution. I start with this constructing the hypothesis. Okay, I'm gonna construct the hypothesis. HO pi 1 equals pi 2. H1, the alternative, pi 1, pi 2. So we need to have a sign either less or greater. So we need to know which one, what pi 1 is, what pi 2 is. First, this is what we know in the beginning, at the very beginning. Using a PC, let's say pi 1 is a representation of people using conventional PC. So if it is greater for using in a mobile internet, so pi 1 is for a PC, pi 2 for mobile internet, so it is greater. Read the statement in here, whether the population success with the conventional PC is greater than, this is the question, greater than that when using mobile internet touch screen phone. So I assign pi 1 for user using conventional PC, pi 2 is for the mobile, so I can have it as larger. And the alpha level is also given 0.01. Okay, and N1 is 500 and N2 is another 500. For each samples, 500 person are assigned. And P1, the first sample proportion, the success rate for achieving, okay, since pi 1 is for people using conventional PC, so P1 is going to be 0.80. P2 becomes 0.75. So before I get the calculated statistics, I need to have the P bar, which is N1 P1 plus N2 P2. This is divided by N1 plus N2. Okay. So this is equals, let's see, 500 times 0.80 times 0.80 plus, I made a mistake in here, 500 times 0.80. So I need to get back 500 times 0.80 plus 500 times 0.75. This is divided by 500 plus 500. And the result, if you get it done, you'll see that this is actually 0.775. Okay, now you can get directly to the calculated statistics, which is the Z calc. This is P1 minus P2 divided by P bar times 1 minus P bar times 1 divided by N1 plus 1 divided by N2. Okay, let's get the result done. 0.80 minus 0.75 and divided by the square root 0.775 times 1 minus 0.775 times 1 divided by 500 plus 1 divided by 500. So I'm gonna enlarge this. Okay. The result, let me get you the result. I'm gonna use my mobile phone as a scientific calculator. I don't really have the result. So 0.8 minus 0.75 within the square root 0.775 times 1 minus 0.775 time 2 divided by 500. The result is 1.8932. That's the calculated statistics. Okay. And let's have this picture right here. Okay, copy this picture. Okay, copy. So I like the picture, really. All right. And since the alpha is 0.01, I don't have a rejection part in here. So I don't have the rejection part in here. Okay. Delete this. And I have 99%, so the rejection part will be okay right here. So this is the rejection part. Okay, that's a reject. This is 0.01, and so I don't have 0.90 here. It is 0.99. This is, let's use this one, 0.99. Okay. The rejection part, let's highlight it. Okay. I made a mistake. Highlighting, that's this one. Okay. So the rejection region, we need to get the critical value from the standard normal distribution table for 0.99, not 0.01. let's read it carefully from the table, standard normal distribution table right here. 0.99, I have this one here, 0.99, so it is 2.3. You have 2.3 here from the row, 0.3, so in total it makes 2.33. Okay, so this is, it means the critical value will be 2.33. 2.33. Okay, the calculated statistic is 1.8933. So it will be simply right here. Okay, 1.8932 is falling with the accept region, so we do not, since 1.8933 is less than 2.33, then we do not reject the null hypothesis. With alpha equals 0.01 level of significance. So that's the conclusion in the end. So it means the population success rate with a conventional PC is not greater than when using the mobile internet and touch screen phone. Okay, so this is means, in other words, the population success rate, with a conventional PC is not greater than that when using the mobile internet. Okay, this is a very basic answer for this, and this is the comment you make in the end of the question. Let's have another one, study another one from the Introduction Business Statistics book. 11.56. Let's keep going with this exercise. Copy it for you. And right here. Okay. 11.56. Let's move it down. Okay. That's the question. 11.56. In a study by the United Dairy Industry Association, 42% of 655 persons aged 35 to 44 said they seldom or never ate cottage cheese. For 455 individuals aged 45 to 54, the corresponding percentages was 34. At the 0.01 level, can we reject the possibility that the population percentage could be equal for those two groups? So this is the first exercise, the first example. Probably we do not have equal sample sizes for two different samples. In one, notice that in one is 655. This is N1 and this is N2. They are not equal size. So it means it's not necessarily mean that we should always have equal sample sizes. This is not true actually. So the question for the solution, before you start the solution, we definitely need to write the hypothesis first. We always construct the hypothesis. Okay, let's construct it. And alpha 1, the HO equals pi 1 equals pi 2. The alternative hypothesis is not equal. We understand this is from the last statement of the exercise. Read that could be equal, so will result with not equal. So this is why you construct it as not equal. Okay, the alpha level is given 0.01. So this is the alpha level, 0.01. For pi 1, P1 equals 0.42. P2 is 0.34. Okay, and we need to get the result for P bar equals, this time is different. We don't have a common sample sizes. So, and let's write the sample size as well. And one is 655, and then two is 455. 655 times 0.42 plus 455 times 0.34. Okay, this is divided by 655 plus 455. Let me get the result straight to you. Okay, 655 times 4.42 plus 455 times 0.34 divided by 655 plus 455. Okay, the result is 0.387. That's fine with 3 digits. That's okay. This is the common population rate, estimation of population rate. So the calculated statistics is now performed. The calculated statistics. Okay, this is 0.42 minus 0.34 divided by the square root. Okay, 0.387 times 1 minus 0.387. 1 divided by 655 plus 1 divided by 455. This is, okay, let's get the result. Point 42 minus 0.34 divided in the square root 0.387 times 1 minus 387 times 655 plus 455 reciprocal, and the result is 2.691. Okay, with 3 digits, fine. Okay, this is the answer, 2.691. Okay, this is a double-sided for 0.01, and the critical value, gonna copy this again. I like this picture. Okay, made a mistake. Select this picture. Okay, copy this one right here, have it right here. Okay, I'm gonna resize it. Okay, fit it right here. I want it to fit here. Okay, the calculated, we have 2 rejection area, one in here on the left side, one on the right side. So I have another rejection part here. Okay, and this is another rejection. Reject here gets to tick. I'm gonna have it lighter. Reject. This is 0.01. Sorry, this is 0.0005, and I also have this one to be 0.055. Oh, 5. So these are the accept regions, 0.99, and I'm deleting this one. I don't have 2.33, it is different now. I'm gonna check from the standard normal distribution table in the end of the document right here. Okay, for 0.05, so it means 0.995. This is the one you need to look for, 0.995. Do we have this? I'll try to look for this one. Yes, we have 2 of them in here. Okay, 2 of them are very close. Okay, those 2 very close to 205. So in average you can take the average 2.57, either 57 or 58. So you can take the average, fine, could be fine, the average. So I'm gonna take the average, so this is going to be 2.575. So I have on the left side minus 2.575. So this is a plus, I made a mistake here. So I have on the left side is a negative value, minus 2.5, 7, and 5. And the calculated statistics is 2.691. So simply will fall within the rejection part, and this is not true anymore. I'm gonna write the correct one. Okay, this is 2, the calculate 6, 9, and 1. That's the calculate statistic, and it falls within the rejection part. So I'm gonna highlight for you the rejection part. Okay, I have another rejection part in here. Okay, so since the calculated statistics is falling with the rejection region, is exceeding the critical value, since um, okay, since 2.691 is greater than the critical value 2.5, 7, and 5, we reject the null hypothesis. So in the end, what you say that we reject the possibility the population percentage could not be the population percentages could not be equal for those two groups. Two groups. You can also construct the confidence interval. Let's perform the confidence interval. For this, we will expect the confidence interval will not include the zero value because we reject the null hypothesis. So let's construct it just for practicing. Construct the confidence interval for two population proportion difference. With 99% reliability. Okay. Okay, remember the confidence interval from the previous lecture was, let me see that. Okay, we presented you here, except for 1 minus alpha. So I'm gonna copy just as a reminder. Okay, that's the confidence interval. Okay, pass it here. All right. Okay, so we don't use alpha divided by 2. We use 1 minus in here. I'm gonna use 1 minus alpha divided by 2 in place. Okay, in our case, the confidence interval will be 0.42 minus 0.34 minus 2.575 within the square root P1 is 0.42 times 1 minus 0.42. That's divided by 655 plus 0.34 times 1 minus 0.34, and that's divided by 455. So I'm gonna extend the square root. So I need to write for the upper bound this as well, so it won't fit here. Gonna place, okay, all right. This is the square root. Okay, so this is less equal pi 1 minus pi 2 plus equal. I'm gonna copy it again. I have very few things changing. Copy, all right. Copy, just paste it here. All right, it's not. All right, okay, made a mistake by the highlighting. Okay, copy. Okay, it seems that it doesn't fit in here, so I'm gonna get it smaller right here. Let's have the lower bound to be smaller too. So this is going to be plus. This is plus. Let's get it smaller too in here. Okay. All right. That's the confidence interval. I don't need that. Okay. So the lower bound, let me get this calculation done. The lower bound I'm expecting to be positive, and the upper bound is also going to be positive, and with the confidence interval will not include the zero value. 0.32 minus 0.44 minus 2.575 times within the square root 0.42 times 1 minus 42, that's divided by 655 plus 0.34 times 0.66 divided by 455. The result is the lower bound is 0.0004 less equal pi 1 minus pi 2, and the upper bound um, 0.156. That's the confidence interval. confidence interval. Okay, notice that the lower bound is positive, and the upper bound is positive, so it will not include the zero value. So this is why we reject, even if you have the confidence interval given to you, you can easily tell that the null hypothesis for the double-sided will be rejected with 99% reliability or 1% of level of significance. Um, okay, let's move to another one, and we will end up with one more exercise. We'll end up the lecture. 1.11.57 is another one. Another easy exercise. Now you can feel more comfortable to study the other exercise yourself. So I did perform 4 of them for you. Place it here. Okay, that's fine. Okay, the next exercise, 11.57. During the course of a year, 38% of 213 merchant ships lost were general cargo carriers, while 43.8% of the 219 ships lost during the following year were in this category. Using a two-tailed test, so it means double-sided test, at a 5% level of significance, examine whether this difference could have been the result of chance variation from one year to the next. So it means whether there is a difference. That's the question. Let's get this solution. Okay. The solution, the null hypothesis HO is pi 1 equals pi 2. The alternative, pi 1 is not equal to pi 2. N1 is given to be 213. N2 is 219. P1 is 0.38. P2 is 0.438. Okay, the alpha level is given 0.05. Fine, let's get the P bar is, remember from the previous exercise, N1 P1 plus N2 P2 divided by N1 plus N2. This is, okay, 213 times 0.38 plus 219 times 0.438. Okay, divided by 213 plus 219. Okay, the result, let's get the P bar. 213 times 0.38 plus 219 plus times 0.438 divided by 213 plus 219. The result is 409. Okay, the calculated statistics, the Z-calc. Okay, you have 0.38 minus 0.438, and this is divided by 0.409 times 1 minus 0.409 times 1 divided by 213 plus 1 divided by 219. Okay, the result is, let's see, 38 minus 0.438. This is divided by the square root 0.409 times 1 minus 0.409 times 213 reciprocal, 213 plus 219 reciprocal. Okay, that's it. The result is, in my case, 1 minus 1.2258. Okay. This is a double-sided for alpha 0.05. I'd like to have the same picture. Okay, copy this one right here. Okay, right. For 0.05, remember from the previous lecture in the beginning, we had an example. It was 1.96. We determined the critical value for the left side minus 1.96, and for the right side it was 1.96. So I'm gonna fix this here, and this is also okay. This is going to be 95, 0.95, and I will have 0.025 in here, and another one here, 0.025. So this is minus 1.96, and I have here 1.96. Remember from the previous lecture, let me go back to the previous lecture in the very beginning. Not in the very beginning, perhaps. It was, oh yes, here. See that it was 1.96. We determined from the standard normal distribution table. So this is why I place 1.96 in here. I'm gonna highlight the rejection part. Okay, I have another one here. Okay. So the calculated statistics is now small, seems to be minus 1.2258 is simply falling with the accept region. This is minus 1.2258. Okay, the result this time we do not reject the null hypothesis. since minus 1.2258 is falling within the accept region, we do not reject the null hypothesis. With alpha equals 0.05 level of significance. So it means the difference, there is no difference from one year to another year. This is the conclusion. If you construct the confidence interval, this is a double-sided, you will see that the confidence interval will have a negative lower bound and positive upper bound, and it will include the zero value. So it will support your rejection of the null hypothesis. That you should get the same result from the confidence interval. So I'm not going to construct the confidence interval. You can do it yourself at home. Construct the confidence interval for mean difference proportion with 95% reliability. This is homework. So I'm gonna give you some exercise to study yourself and place it in here into your lecture notes, and I will share this lecture note as a PDF file with you from the LabSys and in the DYS system of the university, so you don't have to worry about writing all the lecture notes. I'm gonna share all this stuff with you. So this is okay. The remaining exercise, I'm gonna copy all this page. We study some of them, but you can have all this page exercise. Okay, place it right here, and the next page would be fine. Place it here, enlarge it. Okay, this is the exercise you need to study at home, the remaining 11.58, 11.59, another good exercise. All of them are good. You can study yourself, give time for an hour or 2 hours, study at least 3-4 of them to practice. And the next lecture, we will be studying comparison of two population variances. So this is the end of the lecture. Take care of yourself, and I'll still talk to you in the next lecture. Bye for now.